All right, let's kick things off by talking about how the Jupiter API works. Funny enough, it actually launched on January 1st, 2025. We just did an upgrade. I'm not sure when you're watching this video, but since I recorded it a little over a month ago, our course is still pretty new. So if you really end up watching this video in 2026, it's all good. I bet not much has changed. At most, it's probably just V2 turning into V3. Overall, things are pretty much the same. Before we dive into the Jupiter API, let's talk about what Jupiter actually is and what it's used for. All right, let's check out the Jupiter website. Jupiter is a decentralized DEX aggregator within the Solana ecosystem. It offers a really efficient trading router. It's designed to help users find the best trading routes and prices across multiple decentralized platforms, meaning we're looking at the same assets on each platform. The same token can have different pool depths, and because those depths vary, its price can also be different. Even if you're trading the same amount, the final price on Platform A and Platform B can end up being different because of slippage. The difference can be huge. In other words, the core of GPS has features like aggregation across multiple platforms, like Jupiter. There are decentralized platforms that can aggregate multiple Solana chains, like Serum and Radium. And there's also Jupiter, which has a smart order router. Based on the depth and prices of these markets, you can pick the best trading path. Plus, Jupiter has this smart routing technology that lets you dynamically choose trading pairs at the same time. Make sure the user has the lowest possible slippage for the trade, meaning they can control the price, and they even calculate how many units they're trading and what their slippage is. Then he calculates the slippage for all the routes and gives you the one with the least slippage. So we can just input any token, right? And then add so its price, plus there's a Luyu here, right? After 2 Luyu and 3 markets. Yeah? Which 3 markets are we talking about? It looks like we have the 0 file, Orbro, and V here. These can change anytime, right? Changing to an optimal route means lower transaction costs, which is pretty friendly for developers too. I worked on one of Radium's APIs, and I found it pretty complicated. They only have one SDK, and there aren't any corresponding APIs for me to use. But when it comes to Jupiter, it has some pretty mature documentation and a complete API, which makes it really convenient to use. You don't need to pass too many parameters. For example, in an SDK like Radium's, when you want to make a trade, you have to pass all these parameters. For example, you have pool info, which includes some info about the pool, like its IDs and stuff. You'll also need to do the math for the quantities yourself, but this Jupiter, its API, is just not needed, to be honest. Jupiter hasn't paid me for advertising, but I still recommend it. It's just really simple, all right? The content here isn't too much, and we'll go through everything one by one later. Check out what's inside it and see what it is. Just keep in mind that Jupiter isn't completely free either. It has a paid version and a free version, but the free version has a limit on how often you can access it, which is pretty low. If you want a lot of visits and high traffic, you can use their paid API. But if we want to be a bit clever about it, we could use other APIs too. You can get a price and then place an order using the free Jupiter, but it can be a bit of a hassle. So, how do you get access to its paid API? There's also talk about how clicking on this link takes you to their paid page, connecting to Google. You could try some other accounts too. This one supports Google, and once you connect, you'll land on this page. If you're interested, feel free to check it out and show some support. But just to emphasize again, he didn't pay me for the ad, and I didn't say I needed him to do anything specific. Are we using his free API for our course to give everyone a demo? That's fine, but there's something we need to pay attention to. What about the free plan? It's for swap requests, which is the trading API. You get 1 request per second, so in 60 seconds, that's 60 requests. Getting the prices works the same way. If you want to reach Pro 1, the lowest paid version, you can get access 10 times every second. It can handle 600 visits per minute, so normally, even the lowest paid version can meet a good chunk of the needs. But if we want to ramp up the frequency a bit more, we can also use some other methods, like getting prices from free APIs, and then when we trade, we can use this free one, Jupiter, for the transactions. It's just a bit of a hassle. As for the payment stuff below, We won't get into that because it's all pretty straightforward. When the time comes, we just click to get the key. Then we write this key into this head, and then we can start using it. There's also some basic knowledge for developers to look at together. This is the whole Jupiter. It's built on the Solana mainnet, which means we can't really run any tests on the testnet. So, if we're going to run a test, we're basically using real money for it, and there's no way around that. So we don't really need to worry about the first 3 points, because these are some basics of the Solana chain. But for the fourth point, we can take a look at how transactions are sent through Jupiter to interact with the network. And it includes one or more operational instructions, meaning you can combine multiple transactions into a single transaction to go on the blockchain. In other words, it's supporting this bundled transaction feature. So I swap A for B, then swap B for C, and you just need to write each transaction in the script and it can go on the blockchain. So here, we're building a transaction and then putting that transaction on the blockchain. You can bundle it together for the blockchain as well. All right, that's this part. It's really just some stuff about Web3.js. It's introducing you to Web3.js and how it interacts with the Solana blockchain, along with some of its common features. Our version 2.0, the second chapter of the course, goes into great detail about how it connects to a Solana node using RPC. So, how do we build this transaction and then publish some content onto the blockchain? I think that's what he wants to talk about, and I believe that's really the key point. He said, how do we connect with Jupiter? Well, our course uses this API for the connection, so we can first use the API to get its price and route, right? With this swap API, you can assemble a transaction for it. After we get the transaction, we send it to the mainnet to get it on the blockchain. If it gets on the chain successfully, it means our transaction was successful. There's another way to do it as well. There's something called the flash fill method. Basically, if you're building your own blockchain app, it's a good idea to use this method. It serves as an alternative. CPI is all about calling across programs. This method uses version transactions and an address lookup table to reduce the size of an account ID. Does that sound a bit confusing? So I just checked some info, and what he means is that he's using this SDK, which actually already includes what he mentioned earlier. Basically, we just need to take these. When you input the address into token like we just did, it immediately shows you the corresponding account for that pool, and so on. So like this code here, right? Lines 33 to 40 use this method called flash fill to build what they call a version transaction. Just send it through this alt. And basically, as long as you use this function and put in the input token's address and the output token's address, you're good to go. He can quickly help you find the ID of a pool and generate the transition for that pool. This is his recommended approach instead of using that API. Then coming over to the third point, it's the CPI call. Calling the CPI in the program means using their official Solana CPI call. I guess this is probably the most challenging approach. We need to find this one Jupiter and their program's IDL file, which corresponds to an ID for each pool. The issue is they haven't made this information public, so basically it's a pretty tough call. Our course mainly focuses on the first and second methods, but we primarily stick with the first one. As for the second method, this is kind of like what we showed you all before, a more mature document from Radium. The SDK basically uses a similar principle and needs to pass a lot of parameters. So, how does it update the display? Actually, the SDK includes some content from the API. Some people are wondering if they can bypass the API and just use the official SDK directly, right? It's actually using an API too. Otherwise, how would you update that list of addresses? Have you thought about that? So this part here talks about how it's building this transaction. Transactions mean that before we send the trade out to the network, we have to write a lot of instructions and deal with various accounts, and it gets pretty complicated. But this Jupiter has already set up the framework for us. We just need to fill in some essential stuff. Like here, where we add certain necessary elements. The router also has inputs and outputs, like token addresses and amounts. Once you send that in, it just gives me a transition, which is basically a hash that can be used on-chain. Then we just need to send this hash directly to the chain, and that's pretty much what they're talking about. As for things like broadcasting methods and computing units, these are just some basic operations on Solana. And then there's slip, which I'm sure experienced folks know about. It basically means there's not enough depth. If your trade exceeds the max slippage I set, it just won't go through. That's what I mean. In the next video, we'll give you an overview of what dependencies we need to install when we write a script and also show a demo of the trading part. In the next video, we'll focus on, I just did something on this VS Code. All right, that's it for today's video. See you in the next one.